The first problem says a 50 kg crate shown in the figure rests on a horizontal plane for which the coefficient of kinetic friction is 0.3. So let me mention here mu k is equal to 0.3. If the crate is subjected to a force of 400 Newton, determine the velocity of the crate in 8 seconds starting from the rest. Now, if I want to use the impulse momentum equation, it says that impulse is equal to final momentum minus initial momentum, where impulse is given by F multiplied by T. So I will write F into T is equal to final momentum minus initial momentum. Now if you observe in this, we require the force. That means all the forces acting on the body. So to find out what are the different forces acting on the body, what we do, we draw the free body diagram. So let us start with that. So we have a 50 kg block. The first thing which we show in the free body diagram is the applied force. So it is given the applied force is 400 Newton acting at an angle of 30 degrees with respect to horizontal. Next we show as the self weight acting downward, so it will be 50 multiplied by 9.81 because we need in newtons. Third is the reaction from contact surface. So yes, the block has contact with this surface, so there will be contact reaction, let us say it is N. And last we show the friction force. So friction force in the direction opposite to the motion of the body. So it will be like this with a value of 0.3 multiplied by N. With this we have completed drawing the entire free body diagram of this particular body showing all the forces acting on it. But to apply the conditions of equilibrium or any condition of impulse momentum, all the forces should either be in x direction or in y direction. This force of 400 Newton is inclined at an angle of 30 degrees. So first what I will do, so I will resolve this component into two parts, that is 400 cos 30 and this will be 400 sin 30. Now we can apply conditions of equilibrium, or you can say impulse momentum equation, on this particular diagram. So let us start with that. Applying impulse momentum equation in y direction. So by impulse momentum equation we have mu plus impulse is equal to mv. So substituting in place of impulse F into T, I will get mu is equal to summation of F into T is equal to mv. Now why summation of F into T? Because there are number of forces acting on this body. There is one force here, this is the second force, third force, fourth force and fifth force. So I need to take into account all the forces acting on the body. Hence I have written the word summation of forces multiplied by time. Now substituting the values, I will get M, we are given to us in the question that it is 50. U, it is starting from rest, hence it will be 0. Then summation of all the forces in y direction, because I am applying impulse momentum in y direction. So this will come 400 sin 30 going upwards, then 50 into 9.81 going downward, and this n going upwards. This all forces multiplied by time. So it is given to us in the question that find velocity of the crate 8 seconds after starting from rest. So time will be 8 is equal to, again mass is given to us as 50 and 0 because there is no velocity of this body in y direction, hence it will be 0. If you observe this figure, this block will move along this direction, that means it will have velocity in x direction and the velocity in y direction will be 0. Hence here I have written final velocity in y direction as 0. Now solving this equation, I will get the answer for n as 290.5 newtons. Now as we applied the impulse momentum in y direction, we will now apply the impulse momentum equation in x direction. Again same I will write mu plus impulse is equal to mv, where impulse I will substitute now it as mu is equal to summation of ft is equal to mv, where now this summation of f will be the forces acting in x direction. So forces acting in x direction are this one 0.3 n and this one, that is 400 cos 30. So substituting it, I will get 50 into u. Again, it is starting from rest, hence it is 0. Summation of, in place of forces, we have discussed that there will be two forces, 400 cos 30 and minus 0.3 n. Time is given to us in the question as 8 seconds, is equal to, again mass is 50 and velocity, let it be v. Now in this equation, there are two unknowns. One is this n and one is this v, out of which this n we have already found out. So what I will do, I will just substitute this value of n here and I will get the equation as 50 into 0 plus summation of 400 cos 30 minus 0.3 into n, which is 290.5, multiplied by 8 is equal to 50v. So on solving this equation, I will get the answer for v as 41.48 meter per second, and this completes the solution. We were asked the question to determine the velocity of the crate in 8 seconds after starting from rest. So my answer will be the velocity of the crate 8 seconds after starting from rest is 41.48 meter per seconds, and this completes the solution. Thank you.